Okay, so let us get started. Many of you has many questions. Now I am here, you can bombard me with questions. Yes, so many of you has doubt regarding how come m double prime comma w is a blocking pair for this stable matching m prime. So, let me slowly go over to the argument once more. Huh? Okay. So, we are in the case where at the I plus 1th iteration there has been one rejection, because otherwise we have the result from induction hypothesis. So, in the I plus 1th iteration, suppose M is a man who has proposed a woman W, and this woman W rejects either M or her previous partner. That guy I am calling it M prime, and she is with M double prime. Okay, both M prime and M double prime, one of them will be M and the other will be the original partner. So, I know this, that this woman W definitely prefers M double prime over M prime, because among M double prime and M prime she has chosen M double prime. So, this I know, and in Ri plus 1 I have a new pair M prime comma W. So, for all other pairs are in Ri also, and for those pairs I have the result by induction hypothesis. What is the result? That there is no stable matching where any pair in Ri can get matched. Okay. Now, I want to show that there is no stable matching which matches M prime and W. So, it is a proof by contradiction. Suppose there is a stable matching M prime, I do not care how it is obtained, okay, some stable matching M prime which matches M prime comma W. So, it is a proof by contradiction. We are assuming the exact opposite of what we need to prove, and we will find a contradiction. What contradiction here? We will contradict to the fact that M prime is a stable matching. By how? By showing a blocking pair for M prime. What is the blocking pair? The blocking pair will be M double prime comma W. Now, for M double prime comma W to be a blocking pair for M prime, I need to show two conditions, that this man M double prime prefers W over his current partner, and this woman W prefers M double prime over her current partner under M prime. Make sense? So, one of the inequality I already have that who is the current partner of W? M prime. So, W already prefers M double prime over M prime. So, I only need to show this. Now, let us look at the ranking or preference of M double prime, which is irrespective of stable matching, that is the input to the problem. Suppose this is the ranking, W appears somewhere. Do you see that all the pairs M double prime comma W1, say M double prime comma W1 belongs to Ri, because in the Gale-Shapley algorithm at the ith iteration, after the ith iteration means while loop. When I say at the beginning of ith iteration, at the start of the while loop, at the end of the ith iteration, at the end of the while loop, all the statements, 3-4 statements we had, that is one iteration, beginning of the while loop, end of the while loop. You can replace iteration with while loop, body of the while loop. So, at the end of the I plus 1th iteration of the while loop, W is matched with M double prime. That means M double prime has already proposed W1, W2 till W just before W and got rejected in the first I iterations of this particular run of the algorithm. So, that means all these pairs belongs to Ri. Now, I use induction hypothesis that there is no stable matching where M prime is matched with W1, M prime is matched with W2 and so on. So, in particular in this stable matching M prime also, the partner of M double prime can be below W or W, but W is partnered with M prime. So, the partner of M double prime can be below W. If I write that statement mathematically, it is this, the other condition of blocking pair. So, this shows that this is the blocking pair, M double prime comma W is a blocking pair for M prime, and hence such a there cannot be a stable matching like M prime, where M prime and W is matched. Okay. So, this proves the theorem. Now, as very importantly pointed out that this whole theorem is proved, these things Ri, R, these objects, these sets are defined with respect to one execution of the algorithm. Now, for different executions I will have different Ri's, different R's, different incarnations of the theorem. Okay. Then things seems not so much useful, no? Am I making sense? All these sets Ri, R, this theorem is defined with respect to one execution of the algorithm. So, whatever you have proved is just for one execution of the algorithm.
R can be any arbitrary R, right?
No, it is defined with respect to one execution, right?
One execution.
Yeah.
It's true for all kinds of such executions, right?
Yeah, so let us see. So, first I say that, okay, so first I claim that, you know, although these Ri's can depend on execution, this set R is same for all execution. Let me repeat, although Ri's can be different, this set R is irrespective of the execution. That means what? I run, you define your Ri's, I define my Ri's, take union, their union must be same. Can anyone tell me why? Yeah, good. You know, nowadays in life and in research also, fairness is very important. So, I would request the other guys who are not talking, please show up. You also have paid registration fees. So, why use, ask me, okay, ask me and try to participate.
I will just add, more questions you ask, good or bad, likely it is that you get an honorable mention or special mention from
Oh,
ACS.
super. Yeah.
So, yeah, I should have announced that at the beginning. That's also there.
Oh, that's also there. Yes. Yes, please ask. Yeah, please ask. You also come. There are few guys who have just seen this and they are answering. But you know, others also please answer. So first, let me write the execution. So let E1 and E2 be two executions of the algorithm then let me write this notation that R E1 as he rightly pointed out, all these sets you are defining is with respect to one execution. So, there ideally should be a subscript somewhere, this execution should be there. So, now I am finally putting it there, I did not put, it will be cumbersome. I claim R E1 should be equal to R E2. Not you, anyone else, can someone tell me, especially who have not spoken yet, why this should be same? Do you see that these sets are defined with respect to the execution of the algorithm? So, these RIs are definitely different, there can be different, but this R which is defined in terms of Ri's, the T can also be different. Why R should be same? Anyone else? Anyone other than that lady? Yeah, she has already answered. Not difficult, easy. Everything in this table matching world, I will teach only easy things. She will teach difficult things. For me, everything is easy. No prerequisite. Everything is like puzzle.
Theorem is specific to the execution of the algorithm.
Correct.
But still, in the theorem, there is no stable
Exactly.
match.
Very
so
good.
that's a
Very good. So you have hit the bullseye. But you know, if although everything is with respect to this table matching, this execution, you know, focus this any. This is a global statement. So suppose these are not true. Suppose these are not true. So tell me. Okay, let me see here. So suppose these are not true. So for contradiction. Suppose R1 E1 is not equal to R1 R E2. That means that implies there exists a pair which belongs to one set, does not belong to other set, right. So let us assume this belongs to R E1, but does not belong to R E2, right. Now look at M's preference ranking. Can you tell me who is the partner of M in this execution E1? Where the partner of M, eventual partner of M in the execution of E1 can be? Below W. So here in this region. So all those things, these are rejections. Now apply that theorem on R E1. That means there cannot be any stable matching where M is matched with any moment till W. So partner can be from till here. But you are saying M was never rejected by W in this execution. So in this execution, who is the possible partner of M? Above W. And that is also stable matching. We have proved that it does not matter which unmatched man you pick, the output of Gale-Shapley is a stable matching. So in that stable matching, M is matched with a moment better than W, but then that is contradicting the theorem for E1. What is the corresponding theorem for E1 says? That there is no stable matching where M is matched with any moment till W. What are you saying in this look at the output of E2, there M is matched here. You know, I have a very bad habit of rushing, so please feel free to say or remind me that can you please repeat. This is a safe statement. In any class you can say, sir, can you please repeat. Maybe you could not follow, sir will ask something, can you please repeat it. I did not understand completely. You will repeat. Anyone want me to repeat? Let me again repeat. So because M is rejected by W, the possible partner of M in E1 is below W. That means by that theorem M can never be matched to any moment till W in any stable matching, but in this stable matching M is matched. So there is a contradiction. So this set R does not depend on execution. Which unmatched man you are picking does not depend on it, right? What do I mean by 2 executions? It depending on how you pick the unmatched man. You pick some by some algorithm unmatched man, I pick some by some method. My execution is E1, your execution is E2. These are our R sets, rejection sets, and this should be same. That is what this says.
The exact contradiction will be that in RE2 there will be a case where the M is matched with someone with above W, say M and W1, for example.
No, I am not getting. So is it not a contradiction?
So that will be a contradiction. Let M comma W1. So in RE2 the
Yes, M is
in
matched
that
with some.
execution
Right, yeah.
W1 agreed with M, but in this execution it did not. So this is the contradiction.
Correct, exactly. That's what I am saying. So here M was matched with some woman better than W, because M W has not rejected M.
So it could be W also.
Yes, correct. Up till W. Correct. Thank you. Yeah, very good point. That's what I am saying. I keep on making many wrong statements till W, because W has not rejected M. So the possible partners of M in E2 is W1 till W, which are not allowed by theorem applied on RE1. Okay. Now tell me, I have run an algorithm, I give you R. Can you tell me what is the output of the algorithm? Stable matching, but can you tell me what is who is matched with whom?
Some kind of
Exactly. So R gives all information you need to say what is the output. How does R look like? For every man, say M1, no, there are list W1, W2, and for some till Wi, all these pairs belong to R, M1 comma W1, M1 comma W2, and so on. So if for every man I see, I go over its preference list ranking from top and see till which woman it is paired in that rejection list. That means the next woman is his partner, right? Because every man proposes from most preferred to least preferred, right? So if woman W1, W2 till Wi has rejected and Wi plus 1 has not rejected, that means M1 is partnered with Wi plus 1. Does it not prove that irrespective of the choice of unmatched man, the output of stable matching, Gale-Shapley stable matching is same, because R is same? Irrespective of the execution of the algorithm, if R is same, output is also same. Can anyone help me proving the second part, controversial second part? The number of proposals are also same. What is the number of proposals?
R plus
N. R plus N. NO dot shorthand for number. So you see the number of proposals are also same. So number of iterations is also same. This is the number of proposals, and which is same as the number of iteration, because in every iteration there is exactly one proposal. So number of proposals is same as number of iterations, is same irrespective of how you pick unmatched man. Okay.
So if you take a simple case of say 2 men and 2 women, and the preference list is that I have here one.
No. This is a tutorial problem for yourself. That either you find a counter example. If you have found a counter example, then this algorithm, this proof is wrong. There is some bug. Find the bug.
Like in this example, I think it is contradicting.
Yes, I agree with you. So the question is find a bug. That is a home task. whoever finds a contradiction, then for him the question is find a bug in the proof. In this world, in this era of chat GPT, so what we sometimes do, we ask chat GPT to prove, and many times there are subtle bugs, and that you can improve. You can say that there are bugs, fix it. Then the obvious bugs will gone, and there will be subtler bugs, and we give that thing in the exam, find bug. The bugs become subtler and subtler. So, here also there could be bug, I agree with you, there could be counter example, and yeah. So, find that bug. Okay, so but is this clear that we have proved this theorem, that the number of iterations, output is same, number of iterations is same, number of proposals is also same, number of proposals is same as number of iterations. Okay. Any question before I erase everything? Because next what I will show another cool thing is that this proves more. Does this not prove that every man is matched with the best possible woman over all stable matchings from that man? Correct. Because if some woman rejects man, that woman will never get matched in any stable matching. So, as a corollary again, in the remember H of A is the woman for that man A, who is the best across all stable matchings, best possible partner of A, best in the sense of the preference ranking of M. Yes, H of M, H of M, correct. Thank you, ma'am. Yeah, right. So, this altogether, this this seems like a theorem of no use, is giving these big things as corollary, that if I just match every man to its H of M, it was not clear whether it is a matching, forget about stable matching. It shows that it is not only matching, but stable matching. More, I claim this shows that this is the worst possible scenario for the woman. This is woman pessimal. That let us define woman pessimal as intuitively, as the name suggests, across all stable matchings, every woman is getting her worst partner, getting matched with her worst partner. Is this clear? Corollary of this maybe again. Yes, I am saying it, no, not clear.
Because the man has control. Like if a woman wants to get
This talk is getting recorded. So whatever he said, he has said, I have not said. So if any lawsuit is there, it will be against you. Yeah, sorry, yeah, please carry on. Go ahead. Yeah, please carry on, sorry. Yeah.
Yeah, because if you want to form a pair M comma W, the M has to propose to W in order to form the pair. So therefore, W will get the worst possible. She'll not get a better one because from the other side it might not come. The proposal.
W only gets a proposal if everyone above W has rejected the proposal. Why?
Yeah, but this claim is over all stable matchings, not restricted to some particular run of GS algorithm. Yeah, these arguments seem correct, like the news channels arguments. Which looks correct and true. But yeah, seriously, can you give me 1 2-line proof? Use this. We have everything on the board. Use this.
We have only one stable.
No, there are instances. Okay, so we'll come back to it. But there exist instances where there are exponentially many stable matching, and this was a very active area of research. There was, I think, few years ago a soda paper, which I think pinned down up to quite closely that what is the exact exponent. I don't remember exactly, but there can be exponentially many stable matchings of an instance. Let's settle down. There can be exponential in n. C to the
global constant C.
Correct.
And they didn't optimize the C.
Okay.
They say that this is highly under optimized. We just show for the first time this is C bar n in fact.
Correct. Okay. Yeah. Some C power n for some constant C. Those many stable matchings could be there. So there can be instances where there are lots of stable matching. But yeah, frankly, the proof is just 1 line and this on the board. Yeah.
So because R is not changing with any execution, so the set of pair of rejections are constant, like they are the
Fixed.
same, fixed. So a woman is forced to pick someone in the least order who is not rejected. So
Yeah, sort of. Yeah, let me. So, yeah, let me clean up the board slightly. Or, let me not do it. Huh?
If we take a contradiction that there is a stable matching, wherein the woman is matched with some man better than her.
Fine. So, what I will do, it's fine. So, I'll give it as homo. I think we have a tutorial session also, right? Tomorrow, right? Yeah. So, we'll discuss this. Yeah.
But can we use the above one to?
Yes, you can use whatever is taught, not some other. Whenever I come to CMI, I'm afraid they will bring, I don't know, algebraic geometry, manifold. Please don't use them. Use simple things. And okay. Let me erase the board completely.
game more fair, can we make a rule where every man has to propose every woman?
No, it's
In that
already
way-
fair in the sense that you can always read or listen to this lecture with men and women swapped.
No, no.
But yeah, you say yeah.
If we are consider a male optimal or the algorithm, so can we make it in such a way that every man has to ask every woman? In that way, the woman can actually choose a person she likes rather than choose from the person's choose from the male who likes her. You know?
Yeah, and that again sounds reasonable, like again intuitive and those debates. But can you prove guarantees? But that's a very natural question, and it is a well-studied question. It's like this that we'll see that there are lots of structure, and can we find a stable matching which is somewhere in between in fairness sense between men optimal and women optimal in more concrete sense. I just don't have, I have not just introduced those things to pose this question formally, but this has already been studied, and many things are known.
Sir, how can we concretely define fairness here?
As I told you, I have not discussed the framework yet to formalize it. But there exists a framework. I may have time to introduce it to you, and if I can, I'll pose it formally also. But it has been studied. Here is another nice, cute exercise. Again, very simple logics we will do. There is no matching. Given a stable matching instance, there is no matching. Forget stable or not. There is no matching where every man is matched with better woman than H of A. There is no matching where every man gets better partner.
At least a better partner.
I think better partner, at least then you can get that, or better partner. There is no matching where every man gets better partner than,
Strictly better.
yeah, strictly better.
Yeah?
Yeah.
Yeah. We want to say this is Pareto.
Yeah, this is Pareto optimal, correct. So, let me see again if everyone has got this. There is no matching where every man gets better partner than men optimal stable matching. In men optimal stable matching, every man's partner is the best possible from that man's perspective over all stable matchings. The question is, does there exist a matching, forget stability, just matching, perfect matching, where every man gets better partner? So, the answer is no. Again, few lines, proof, easy.
Every man gets at least as
No, not at least. Oh yeah, every man gets at least as good.
And one person gets strictly
I am
better.
asking even weaker question. I am asking some easier question. No, I remember I was in your position. क्या बोल रहा था, and these many CMI guys, they know everything. So I was asking, remembering myself in your position, struggling. So this one. So every man is getting better, but what these experts are saying is true, that there is no matching where all of them are getting every man are getting at least as good as, and at least one man is gets strictly better partner. There is also no such matching. Forget stability. So in that sense, this men optimal stable matching is what is called Pareto optimal. Pareto optimal means that without making someone worse, you cannot improve anyone. That is Pareto optimal. Some sense. It's fine if you did not get the last part. Okay, let's ask the next important question that we always investigate in game theory, which is it strategy proof? Because who will report my ranking? I will report. So if misreporting my ranking gives me better partner, then although I am a faculty, I think I should do it. So I think you and it's a valid question, right? So what is the question? This input, what is the input? Remember, every man and every woman reports their rankings, which they know. So they have the freedom or liberty to misreport They can say no, my ranking is this, and whatever they say you have to believe, because you have no other way to learn. So, the question is it possible for any man or woman to misreport and get better partner? Okay, is the question clear? The answer, let me tell you the answer and then we will prove. So, if I look at men optimal stable matching, then for women it is possible to misreport and get better partner, but for men it is not possible. Okay. So, the answer is this, now we will prove it. So, let me write here. Okay. So, for women it may be possible to misreport her preference and get better partner. So, to prove this, all I need to do, I need to give you a example instance where a woman can get better partner. So, proof. So, here is the instance. So, with 3 men M1, M2, M3, W2, and the preferences or women are M1, M3, M2. So, let us first find out what is the outcome of men proposing algorithm. So, let M1 proposes W2 first. So, I have M1 matched with W2, let then M2 propose W1. This get matched. M3 propose W1. So, W1 now has 2 choices, M2 and M3, and accepts M3. So, this gone, M3 W1, right. W1 after receiving proposal from M3 rejects M2 and accepts M3. Then M2 proposes W3 and that is it. So, this is the outcome of men optimal men proposing Gale-Shapley algorithm. Fine. Now, let us change the preference of M2 to this thing. For women, yeah, what I want to show is that it is possible for a woman in some instance to misreport her preference and get better partner. Sorry?
I think you said M2 wanted to say W1.
Oh, I said, oh, change, no, yeah, W, yeah, I will change men's preference, yeah, women's preference. So, W1's thing, let's change it to M1, M2, M3, and now let's run. Okay, so M1 proposes to W2, M2 proposes to W1, M3 proposes to W1, but gets rejected. So, that is not there. Then again M3 proposes to W2 and this guy gets rejected, right, because W2 prefers M3 over M1. Then M1 is left, M1, then M1 proposes W1, M1 proposes W1, right, because W1 prefers M1 over M2, and I do not care what happens, but once M1 gets attached with W1 and W1 is M1 likes most, then at the eventual matching M1 is matched with W1. So, W1 gets better partner, best partner by misreporting her preference. Yeah, that I also do not know. I do not have much clue about this. Yeah.
No, what I was asking is, can women compute what they should report?
Oh yes, that is a very nice question, and that is a very important question in algorithmic game theory. So, typically in game theory, people show that something is not strategy proof. What does that mean? That there can exist an instance where there can exist a player who can misreport and get better thing, and that is where classical game theorists stop. No, that is bad. And there computer scientists pick up and ask the question, okay, but what is the computational complexity of this strategic manipulation? Because if the number of men grows, then iterating over all rankings is infeasible, right. So, it is an interesting and it is well studied question that what is the complexity of this problem, which Shushmita, do you remember what is the complexity of this problem?
That there is a woman who can find out.
Correct.
You can do it in basically a woman you take out. You can always do an order n cube.
Order n cube time. So, it is polynomial time solvable.
So I have a couple of first question is like, is it execution independent, like the run of the is it just the outcome of the?
Yes. So, if a system will tell that we will find the matching based on men proposing Gale-Shapley algorithm, because the system transparency, this is an era of transparency, you have to tell what algorithm you are following.
And the final final matching is stable with respect to the
Input.
the white color one.
For white color one, this is the stable matching.
Yes.
For white and replace this with this,
Yes.
then this is a stable matching. I have not written the final, but the final does not matter with respect to W1, because W1 irrespective of who else proposes will not accept that proposal. W1 is matched with M1. W1, this woman, if a woman is matched with the best men, then the woman will always reject subsequent proposals, if any. So, it does not matter what is the eventual stable matching, that woman this woman W1 is matched with M1. So, from this woman's perspective, this W1, this woman was getting matched with M3 in the white matching. Now, by misreporting her preference to be this, she is now getting matched with M1. So, she has got better partner.
She has got better partner, but the overall matching is stable with respect to the original thing needs proof.
Not original thing, this thing. So, it is like think of this woman's perspective. She does not care whether from with respect to original thing whether it is stable or not, bhar mein jaye. This is my ranking by preference, am I getting better? So, this output will be stable with respect to new preference, not original.
So, Vishwa, what you are asking is a much more stringent requirement. Can a woman manipulate in a way that the resulting outcome is strictly better for her and
be stable.
somehow it is stable with respect to the old preference?
But that is, see in strategy proofness, that is not what woman cares. In typical game theory, in even normal game theory also, when I say manipulation, there is concept of manipulation, strategy proof, incentive compatibility. Incentive compatibility and strategy proofness, those are from the point of view of particular agent. Right, same here, strategy proofness, asking can one agent misreport her thing, her information to the system, so that the outcome is better for her.
So
Right.
in this scenario what we did, so here it was one-sidedly W1 got better and maybe M1 got like his second best option, but like so it is still a like it is not a blocking pair that is being formed.
That will be a stable matching with respect to these new preferences.
Like considering the orange one that we have got and taking the old preference, still it will be a stable matching, right?
And that needs a
Blocking
proof
pair
to
won't
me.
be formed.
That needs a
In
proof to me,
this-
I am not very sure. So, he is claiming that this stable matching, this matching is a stable matching with respect to original preferences.
Yeah, at least in our case, it is there. Right?
Not clear to me.
So, this yellow stable matching, you just built it. Was that a woman optimal stable matching?
No, men, I am running men proposing Gale Shipley.
But the yellow matching is a different matching, right?
There is a different matching with respect to this ranking. That is why these colorful chalks are helping me. So, this color corresponds to this color.
Okay, Palash, but potentially if truncation was allowed,
Yeah.
the woman, suppose there are two different stable matching. One, that means there is a man optimal, woman optimal, they are stable from each other. A woman could potentially drop all her partners, all the people behind her woman optimal stable partner.
Yeah, those things
And
are
that
fine.
way you could they could possibly simulate a situation where the outcome of the man proposing gate shift is the woman optimal stable matching.
Oh, yeah, correct.
Truncation is a stronger strategy. This thing.
Yeah,
Commutation is more subtle and more constrained.
yes. Let me not go into it. If you have question, ask Shushmita.
No, I'm
Yeah, but you are right. So, what he basically said is that if truncation is allowed, whatever that means, is that if they can run the algorithm and find out what are the best, what is the woman optimal stable matching, and correct, delete the preferences men below that list.
So then we can extrapolate the situation that such a case wouldn't come making n square iterations.
Yeah, it opens a Pandora's box. That's why I am not going into it. But these are good discussions over lunch. And as I said, these are just starting, tip of iceberg. Okay, so let me prove the good thing that this is strategy proof for men. Yeah, sorry. Yeah.
What is the consequence of it not being strategic? So would every woman now be incentivized?
Correct. So for some reason, people think that truth telling is good and lying is bad. I don't believe, but that's why these big bosses of society think that our mechanism, our system should be such that you will get best by truth telling. This is, if you think of this system, as I said, it has applications to various other areas, like say assigning doctors to hospitals. There also doctors can have incentive to misreport. Does doctors have incentive to misreport his preference over hospitals so that he gets better hospital? So, so then then that is a system level thing, and then the government may ask that can you build a system which is resilient to lie, it's incentivize truth, honesty, and it to incentivize truth. So, if you are honest, tell truth, and that is best. So, from that perspective, this does not incentivize truth telling. That's what that's what this says. But there are various things under the carpet. Do you see that to misreport, to manipulate or strategically manipulate, this woman needs to know all the rankings of other things, which is also practically infeasible in many cases. So, that is why these are the tip of iceberg. There are lots of research going on. This thing is called what the strategy standard incentive compatibility, strategy proofness implicitly assume is complete knowledge. That means all players know the game, all other players, their utility functions, or here in this case rankings, preferences, everything that is a common knowledge. Have you heard of common knowledge? Have you said common knowledge? How many have you heard of common knowledge? Okay. So, let me again say common knowledge is a thing is called common knowledge if not only you know it or not only you know it, you know that everyone else know it, and not only that, you know that everyone else knows it up to infinity. That is common knowledge, and this is a standard game theoretic assumption that the game utility function, in this case these rankings, number of players, everything is common knowledge. For sorry, could you come again? Yeah. So, a piece of information, say I is denote just information abstractly, something. I is common knowledge if all players know it and all players know that all players know it and all players know that, repeat it I times, all players know it. For all natural number I. This is a very crucial assumption in game theory. Without this, whole framework of game theory will breaks down. In game theory, we assume that the game means what? Number of players, the strategy set of each player, the utility function of all players. In that case, here these things, these W's are all common knowledge.
So can I just get back?
Yeah.
So just one point addition. So we implicitly assume this when we analyze a zero-sum game, two-player zero-sum game, because it's a it's a zero-sum game, so you know what the other person knows about you and what their utility is. Okay, so that was zero-sum game automatically gives you that two-player zero-sum game.
Yeah.
But I didn't use the word common knowledge. I may have used complete information setting at some point, but yeah. This is
Are there games where say mechanism designer is also the player of the game?
No, don't digress. First, common knowledge समझ में नहीं आ रहा है क्या mechanism design में.
Like it's somehow the one party, like here it is the man. We get to know their algorithm to assign the preferences, if the other party gets to know it, and if they collude among themselves and they try to get the best out of it. Like they know each other's preferences, and here they know that the first party makes the proposal. Like they have the upper hand in offering it.
Correct.
You have to accept or reject. You cannot make the proposal. So they can take the power out of their hands by concluding it.
Yeah. So
Always
let me come back. Good point. Yours also good point. But let me first finish it. Because I was I don't know, it was going above my head, very much above my head when I got this common knowledge. Just to test whether you understood common knowledge or not, let me give you a puzzle. This puzzle you also, if you solve and you also think where you have used common knowledge. This is a kind of an acid test if you can solve this puzzle. So there is an island and there are two kinds of person, two kind of people. One is white-eyed like us, and others are this red-eyed. The red-eyed are somehow cursed, and if I know that I am suppose I am one such islander, and suppose I know that my eye color is red, I will suicide at a public place in that island at 12 o'clock in the afternoon, in the evening, everyone knows. Okay. Now there is a rule that no one is supposed to talk about eye color of anyone. Use of eye color is banned. Like yeah, in many societies some use of some words were banned. So eye color, that word is banned, and there is no reflecting surface. So basically there is no way of for me to know my eye color. Okay, assume whatever you want to assume, to have this assumption that I have no way to know my eye color. I can see others' eye colors, and there are 500 people whose eye color is red out of 1000. Sorry? No such restriction. Whenever if I know, I will die. Yeah. Lots of places and lots of opportunity if you want to suicide, no problem. In that hypothetical thing, it's getting recorded. In that hypothetical thing, okay, it's hypothetical. Huh? Everything is hypothetical, not practical. Okay, so now one day a visitor comes, and he does not know that he is not supposed to talk about eye color, and he makes a statement that there exists at least one person whose eye color is red. This is a statement the visitor makes. There exists at least one red-eyed person.
500 red is known to all or red?
No, how will I know? If I am red-eyed, I will see 499 red-eyed, and if I am white-eyed, I can see 500. So a visitor comes and just makes this statement and goes away. Will they continue to live as it is, or anything will change? So this piece of information, if you solve this puzzle, I strongly suggest don't Google it. Solution is available on my lecture note. Solution is available. Google it or look at them to spoil your fun. A nice, cute thing. But basically, this illustrates what do you mean by common knowledge. This was knowledge before. Everyone knew that. But yeah. So think about it, and then you will see what is basically common knowledge. Why so much complication? Okay. So let me. Yeah. Sorry.
Coming back to
This example here.
Is that the smallest strategy? Can we claim
With
that
with two.
with two there is no strategy?
No, that also I don't know actually. Yes. Yeah, but very nice question. So let's think all of us together. We have a tutorial session tomorrow. I will also think, you will also think, that does there exist an example where it's a woman can manipulate, but there are only 2 men and 2 women.
Sorry, what's the question? Like, what's the smallest size preference profile?
Correct.
So that
Is it the
the
smallest example? where a woman can manipulate. But even if you get an answer, I think it's a nice tutorial question, right? Yeah, yeah. Because we need some anyway some problems for tutorial. Okay, so yeah, now next come back to this guy's thing. You know, it seems that if I have this algorithm, it may be possible for a set of men and women come together, collude among themselves, and get better. In the sense that in that collusion, no guy is worse off, and at least one guy gets better partner, right? Then that's how a collision, a coalition among friends happen. That if I am not getting bad, worse, and if some of my friends are getting better, I am fine, right? So let's answer this question, and then after lunch we will come back. We will prove that this is strategy proof for men. So that thing is formalized in a notion called core. So let me define it informally, because to define it formally I have to bring in lot of notations which I do not need. So let me informally define. So solution which is in this case stable matching belongs to core if it is strategy proof with respect to any coalition of players. Okay, so it's the generalization of usual strategy proofness where only one player is trying to manipulate. Okay, so let's so what I will prove is that this output of Gale-Shapley algorithm belongs to core. That means it is not possible, it is coalitionally also strategy proof. Coalition of men and women. So let me write the theorem. There are no A1 subset of A and B1 subset of B such that A1 union B1 such that first of all they have the same cardinality, A1 equal to B1 and So, it is a this theorem actually extends the idea of stability. So, if you look at the blocking pair, the notion is that you have a matching, and does or do there exist a man and an woman who can ditch their partners and can get matched among themselves, right. So, this is the extension of this, that it says that you have a suppose this is a matching output by men proposing Gale-Shapley algorithm, and some set of men and women come together and exchange their partners in such a way that that is better for every one of them, and at least one guy benefits. So, this theorem says that such a thing is not possible, right. So, it is kind of an extension stronger than stability. So, proof. Shall I prove these also? Not so difficult. Actually, code is not needed here. I defined it because this is not strategy proof. So, if this is not strategy proof, this cannot belong to core, because core is a solution to be in core is a stronger concept. It is saying that it says that even it is strategy proof against a coalition of players also. But this is not strategy proof for a woman. So, why coalition? Means a single woman can manipulate. But what we can show here a stronger notion of stability, which says that I cannot have a set of men and their partners and somehow exchange them, do the exchange among themselves. And everyone is as happy as before, and at least one guy is happier.
So in the original matching, A1 is matched with B1 set.
To slightly rephrase it. M be the output of GS, okay, so let me say M be the output of GS, and it says that there is no set of men such that these men and their partners, they can somehow exchange among their group without touching other guys, so that every man is at least as happy as before, and at least one man or woman, because they also have need to agree, is better off.
Is this same as the question that you posed before?
Which question I
Like
posed?
you said that given this matching, there is no matching possible wherein you can get a better partner.
I gave a homework proving that it is woman pessimal.
No, you also gave
No,
a
the
homework.
Pareto
There is
Oh,
no
Pareto
perfect-
opportunity. Oh,
there
I
is
no,
no
not
perfect
this.
matching where every man gets strictly
Oh,
better
yes,
partner.
yes, yes. That is this same as for A1 equal to A. This is asking for more.
And even if we take A1 and like we restrict our function there only, so that is a stable matching, right? Which because we are taking that subset.
Are you
of-
saying the proof?
No, no.
Okay.
Like I'm saying in A1 equal to A, it is obviously the same case. But
Correct.
if A1 is subset of A, then also it will
It
remain
needs
same,
a
right?
proof, no, because that M, if it is subset of A, if you run this algorithm on this subset, then
That is still a stable matching, like A1 to MA1, that is a stable matching, right?
that's a stable matching, correct. That's a stable matching. But this may not be the output of Gale-Shapley, because in the run of the Gale-Shapley, this guy may have proposed some guy outside his partner, this set. So, you can't claim that M restricted to this set is the output of the Gale-Shapley algorithm run on restricted to instance restricted to this set. It is not clear, at least. It may be true, but it is not clear. Yeah, I think this also you try to prove. It's not difficult. Yeah.
On A1 might give other output or might not give, that we have to prove.
No, you prove this.
Like,
Have
to
simple
make-
thing.
To make that statement.
There are various ways of direct. सीधा देखो ना, short proofs, short easy proofs. Okay, I think we can then stop now. Yeah. Okay. So we'll meet after lunch, and then I'll prove that. Yeah.
Maybe that's a good. The outcome, the theorem statement there does not require that the resultant matching after rematching is also a stable match.
Correct. Exactly. That's true. Yeah.
It's a very strong statement. Like there is no way you can rematch these people among each other so that everybody, men and women, everybody gets that.
Right. Yes, very correct. Yeah. So you exchange their partners, get another matching. If you look at whole, that did not be stable matching, but can it possible? Is it possible that these guys are better off, or at least not worse off, and at least one of them, one of men and women are better off? It's like institute ने एक allocation दे दिया, then some of your friends you meet together and rearrange among yourselves so that no one is less happy and somebody is happier.